Welcome back to FCosβ tutorial, and today, still on vector mechanics, we are going to be talking about 3D vector analysis. So what you are seeing on board is a diagram drawn in 3D. We are having a cube. Okay, now this diagram contains the x, y and the z axis. Of course, most engineering problems will be dealing with contains just the x and the y axis, but in this one we're having the x, y and the z axis. Now I'm going to show you how we can analyze 3D vectors. Let's say we're having a vector. I'll make use of a force F1, okay, and this force is having an angle. Let's call the angle alpha. The angle to the x-axis, I'm going to call it alpha, and the angle to the y-axis, I'm going to call it beta, and then the angle to the z-axis, we're going to call it gamma. Now, to resolve this force into the various components, all we have to do is first of all resolve it to this bottom part. Okay, now I'm going to resolve it to this bottom part using one of the angles. The angles I'm making use of in this case is the angle gamma. Now remember, when resolving vectors, when you're opening vectors, what we make use of is sine if you are opening vectors. So if I resolve it to this bottom part, I'm going to call it f1 prime, okay, or let's just call it f, and I'm going to call this f prime. Now resolving it, f prime will become f, opening this angle down to this bottom such that the vector lies on this plane. We are going to get f sine of gamma. Now it doesn't matter if in a different book or in a different video you find something like f cosine of gamma, it doesn't really matter. That is, if the angle is with this bottom part, we get cosine, but if it is with the z-axis, we get sine. Okay, next thing we want to do is get the components on the x or on the y-axis. Now to get the components on the x or on the y-axis, fx will be f prime, resolving it to this axis, we are going to get cosine of alpha because we are closing the angle. So that will be f prime cosine of alpha, of which we already know f prime is f sine of gamma. Therefore fx is equal to f sine of gamma cosine of alpha. This is how we resolve to the x component. Now you don't have to start cramming this definition. All you have to do is understand the analysis. In our next video, we are going to be showing a real 3D vector diagram on the screen so you can see how this is actually done. Now this is for x. How about y? To get the results, the resulted components of the y-axis, we are simply going to resolve this one that is lying on the plane down to the y-axis. So that becomes f prime cosine of the angle it makes with the y-axis, that is beta. Of course, we already know f prime is f sine gamma, then fy will equal f sine gamma cosine beta. Okay, now for this one we're having the angle, we're having the resultant components on the y-axis, so it is equal to f sine of gamma cosine of beta. Now how about the z-axis? To get the z-axis, we are not going to resolve to this plane that is at the bottom, but rather it is very easy. We just simply resolve to the z-axis because the angle we're having is directly to the z-axis, and of course fz automatically becomes f, instead of f prime in this case, f cosine of the angle gamma. Okay, so this is the resultant we get when we resolve to the z-axis. Now here we're having the resultant vector on the z-axis and on the x-axis and on the y-axis. Let's say we are to remove it from the Cartesian form. The total resultant vector becomes the square of it. Is like applying the Pythagoras theorem. So we're going to get the square of each component. That will give us f of x squared, fy squared, fz squared. Okay, this is what we are going to get. So the resultant vector is given as what we are seeing here. Now sometimes we might be asked to find the value of the unit vector, okay, or the angle that it makes. It is very simple. There is a general formula used in solving this, and that is cosine of alpha squared or I'm going to put it down because this space will not be enough. So I'm going to have cosine of alpha squared, where alpha is the angle with the x-axis, plus cosine of beta squared, where beta is the angle with the y-axis, plus cosine of gamma squared, and that is equal to 1, where gamma is the angle with the z-axis. So this is a general formula that connects the angle or the relationship between these three guys. So if, for example, we are given a vector that has y but doesn't have an angle to the z-axis, we can just make use of this formula to solve for it. Now, in our future videos, we'll be taking questions on 3D analysis, 3D vectors. Do well to subscribe, share, and like these videos. Also, do well to share to your friends. If you have a question, do well to put it in the comment section, or a topic you'd like us to discuss about, do well to drop it in the comment section. See you in our next video. My name is Dr. Flash. Stay tuned to exquisite tutorial.
Use the link on the description of this video to join our Telegram group for our weekend Sunday free classes for all science students, both aspirants and university students across all universities.